Before we understand how to save energy, it is important to know where it comes from. Fossil fuels are the most common type of source for energy. They are used in factories, cars, electricity, heating, or air conditioning. When fossil fuels are burned, they produce carbon dioxide and carbon particulates. When it is released into the atmosphere, it depletes the ozone layer. This allows for UV rays to surpass the Earth's atmosphere, causing increases in the risk of skin cancer. Also, it raises the Earth's temperature, which further increases the effects of global warming and global dimming.
Coal is an example of a common fossil fuel. It is used often due to how inexpensive it is to produce. However, it creates many pollutants such as CO2 and SO2. Another example is oil. It is convenient for cars because it burns easy and it is volatile, so it can easily evaporate. The issues with this are that it is extremely harmful to the earth, as it contributes to global warming and acid rain. Along with this, when the combustion of oil is incomplete, the products of this reaction are carbon monoxide, which is extremely prominent in cars because of their internal combustion engines. Natural gases do not contribute to acid rain, and they produce less pollutants. However, it still contributes to global warming, and there's a very limited supply available.
Although fossil fuels aren't renewable, there are some types that are, one being solar power. It works by using chlorophyll and using it to absorb the sun's light and photons, which captures its energy to complete a sequence of redox reactions, one of which is called photosynthesis. Blue and red wavelengths of light are absorbed by the chlorophyll in this process, which occurs in a solar cell.
The two half reactions that go into photosynthesis show the loss and gain of electrons during the reaction. The oxidation reaction shows 12 water molecules turning into 6 oxygens, 24 hydrogen ions, and 24 electrons. The reduction reaction shows 6 carbon dioxide molecules, 24 hydrogen ions, and 24 electrons reacting to form glucose and 6 water molecules. This process turns light energy into chemical energy and produces a redox reaction between 6 carbon dioxide molecules, 6 water molecules, and glucose, along with 6 oxygen molecules.
We were then interested in learning about hydroelectric dams, so we visited the Bonneville Dam.
We took a tour of the facility, and while we were there, we learned how it produces electricity that all of us use today. One of the most fascinating parts was when we had the opportunity to visit the powerhouse. It was a lot larger than we expected. When we got inside, we saw where the water went as it passed through the dam. Not only that, our guide used an interactive method to explain how electricity was generated.
We would be nothing without the Columbia River, nothing. So here we go. Columbia River is going to spill into the dam. The water's going to fall. Keep going. 75 RPMs a minute. Keep going. You're spinning 75 times against this. Keep going. Don't pass out. No, you stay still.
You stay still.
You don't move.
Right,
You
so
move.
I get vertigo.
There, yeah. Okay, just go like this. 75 times a minute. Okay. So that's making 13,800 volts of electricity. Keep working. I want my computer to work and, you know, everything, the lights to turn on. You guys can't stop.
No,
This
you
is why
hold
we have,
still.
you stay
Mine
still.
goes like this. I
You
got
don't
you 'cause I'm
move. You
spinning.
do not move. Okay. Then it goes up to 13,800 volts to 230,000 volts. Goes through transmission wires. We step it down. You go home, flip the switch. You make electricity.
This image shows the inside of the inductive motor that is contained within the dam. In the demonstration that our guide showed, the magnet represents the polarity of the 96 magnets, 48 which are north and 48 which are south. This creates a magnetic field around the electric current that would flow into the copper wire.
The reason why electrons can flow through the copper wire is because of metallic bonding. Metallic bonding is a strong attraction between delocalized electrons and positive ions. These bonds have electrons that are highly mobile. They can also efficiently transfer heat energy, and their bonds can remain intact while doing so. When an electric current flows through a metallic bond, electricity is produced.
Salmon and steelhead fish have to swim upstream to lay their eggs, but the dam gets in the way at times. Although there are fish ladders, 4% of them don't make it because they are too frightened or get caught in the blades of the turbine.
It's cute though.
Even though the dam does not emit pollutants, it solely relies on the Columbia River. So if the rainfall is less than average during the year, then the amount of electricity produced is also less.
When creating the Bonneville Dam, 2 man-made islands were also made, therefore impacting the wildlife's regular way of living. For example, the fish are forced to go around the dam or through the ladders, instead of swimming upstream like normal.
In conclusion, we learned a lot from this experience about energy conservation, including the pros and cons for each type of energy. There are many ways that we can improve and help our environment, and a hydroelectric dam is just one of them.